Hi, this is your host Swapnil Bhartiya, and welcome to another episode of TFiR Let's Talk. And today we have with us David Williams, Senior Vice President of Marketing Strategy at Quali. David, it's great to have you on the show.
It's very good to be here. Thank you for inviting me.
It's my pleasure to have you here. This is the kind of first time I'm talking to someone from Quali. Tell us a bit about the company. What do you folks do?
We have a number of technologies that have been in the market for a while. We started off as a company that developed software that enabled infrastructure to be delivered and on demand. So a lot of testing environments were created. A lot of companies use us for delivering a centralized service to their end users by on-demand infrastructure. More recently, we've built technology that is really focused on the application stack and the ability for DevOps practices to be executed with infrastructure getting out of the way of execution. So we've really looked at how you can make infrastructure seamless in respect to delivering technology.
When you said you offer services, in today's, especially in the cloud native world, cloud centric world, we still have on-prem, we also have cloud. But there are companies who offer custom software, they write custom software for their clients. They have a massive team. And then you talked about services, which are, when you offer custom services, then you are creating purely for the client. But when you are talking about services, then it's more or less like a general purpose services that clients use in their own use case. You may fine tune it. So can you tell me the difference between these two, that what exactly you folks do?
Yeah, absolutely. So what we look at the world through environments. So environments are basically combinations of the software stack, the data that you would require, and any services that you would want to include. Like they could be tools. So you might have a whole set of tools that you need to include in the environment. So as a company that is looking to just become a centralized resource that enables requests to come in and for infrastructure to be provisioned on demand, they build the environments up so the customer can actually build these things very quickly by leveraging existing IAC files or YAMLs. And we subsume those and we create those as environments, as well as everything else that they might need. So more additions to tooling, the data. So we actually create environments that are very specific to apps. So if you're doing a testing of an application, you have all the things that you would need to test that application. And it enables people to download that capability. So if you've got a whole team of testers, they can leverage one common source of environment and then choose it through a catalog. So what we're doing is we're making it more available to a larger set of people. But also if there are companies that want to use it as a service with which they provision other people's infrastructure, so they're not doing it for themselves, but they're enabling that to happen. We actually have a very large networking company that uses us for their network of developers. So when a developer comes into their cloud and says, I need infrastructure, under the hood is the Quali technology that actually provisions that for X amount of consumers. They have hundreds of thousands of developers using it, and they can all choose infrastructure configurations either from the catalog or choose the catalog version and modify it to their own needs. It just makes infrastructure go away. You don't want it to become an inhibitor. So our job is to make infrastructure as invisible as possible and not make it a thing that you have to worry about.
Excellent. Thanks for explaining that. That does clear a lot of things. Now, when we look at, as you said, customers can, self-service, they can do it themselves also, or you can help them, which also means that do you support both kind of possibilities, on-prem as well as multi-cloud?
Yes, absolutely. In fact, the company established itself really on the on-prem. We've been around for a number of years, and that was where people were trying to provision infrastructure. So when it came to things like private clouds and the ability to leverage and optimize the infrastructure that they had purchased, and it was an asset. So, in the old days where you had to justify hardware to get a project off the floor, this sort of thing was used to be able to cut the infrastructure up, balance it, make sure that you're optimizing as much of it as possible. And that's really where it came from, on-prem. Of course, over the last couple of decades, cloud has become synonymous. It's the strategic direction. I think the challenges that companies have with their environments today is that we look at environments, the application stack. So you might have your data, managed at different locations. So with edge computing, the cloud infrastructure and some possibly on-prem needs, your application is spread quite broadly, and you might actually do it from multiple clouds. So what we do is we build environments that enable you to look at it from a holistic view and then balance it. And you can you can have the technology in the cloud. So we have platforms that are SaaS based in the cloud, and we actually have the capability of providing on-prem as well. So where you manage from and what you're managing is flexible. You can put it wherever you want.
You talk about cloud, you talk about edge. There's so much to talk about. We can go in so many different directions. But I also want to quickly talk a bit about when you're talking about making the infrastructure kind of go away. I mean, it's not going away. It's just you want to help developers to kind of remove the complexities that come with looking at the infrastructure so that they can focus on writing applications that actually their businesses need. Now, when we looked at, of course, on-prem, you have to do everything yourself. There are different teams, there are silos, they do that. In cloud world, it was more or less like you log into your Google Gmail account, calendar is taken care of, mail is taken care of, sheet is taken. But that is not the case with hyperscale. You still have to deal with so much complexity. And then on top of that, you still have to worry about your application. So can you also talk about the kind of either significance or importance of, once again, your approach, or we can also touch upon infrastructure as code to kind of simplify that word as well.
Yes, it's a space that's changed quite dramatically over the last decade. I would say that there's a number of things that come out from this. IAC was an incredibly good thing to adopt, because what it did was initially, when everything was on-prem, back in the dark ages, you could actually have a centralized source, an IT infrastructure that would provision it. So you'd go for a service desk and they would ask for a request. You would justify the requirements. It would take a long time to actually get infrastructure provisioned. Obviously, over the last decade, things have moved so far away from that, from the on-demand. So as you go to the hypervisor and the sort of cloud infrastructure that enables you to basically just pull a service, it was very easy to do that. So the ability to actually provision things very quickly in the cloud obviously took over, and it really started from the developer side. It was really, because at the end of the day, a consumer doesn't know whether it's cloud. They don't care whether it's cloud. It's only the business and the developer that actually sees a lot of the benefits of a cloud-based infrastructure, because it gives them on-demand structure. All the management that was traditionally an issue pretty much goes away. The cloud provider will move workloads around as they see right. So the ability for IAC to be introduced actually remove the need for a number of things. One, it started to, I suppose the word standardize is a bit liberal, but it enabled people to adopt a common practice of provisioning infrastructure, irrespective of where it was. So IAC was very close to the code. So instead of it being a separate ask and a separate function, so infrastructure, basically you do what your work and then you put the infrastructure together, and then you do more work, and then you modify the infrastructure. It was always an ebb and flow of content. Now you can make IAC an integral part of your coding. So as you need to do something, the IAC comes in, modifies either the provisions of the infrastructure, modifies the configs, moves things around, and it becomes seamless. So at the time when it came in, it sounded like an extremely compelling way to do it. What's happened is, so IAC was all around removing inhibitors, giving coders power, and enabling the business to innovate much quickly. So the problem is that DevOps has become extremely mature. So that's a practice that obviously was enabled by the cloud, and the problem with things maturing is that the business starts getting in the way. So you're no longer able to just use what you want. I'll use the tools I need because you're asking me to deliver something. I will choose what I want and you can keep out of my way. And the business really didn't have a grip on whether it was a YAML or an IAC, or you were just using scripting, or even just the cloud services. It didn't really care. But the problems that has now created have moved IAC to a different type of engagement. So initially it was just the coders would use whatever they wanted. Now the business needs visibility into what's being used. So they want to scale it. So how much does it cost to actually grow the business and adopt these practices? How much control have they got? How much risk are they now incurring if they don't have common governance and policies? So unfortunately, because DevOps has become an adult, it's now matured to a point where it's a grown up and the business is seeing it as a major weapon with which to deliver their business. They need it to be also accountable, which means that maturity has kicked in. And so the way that IAC is being used and the way that configuration files modify the infrastructure, it's got to be more accountable to the business to enable the business to grow, and to scale, and more importantly, it needs costs managed. If you and I were developing IAC code and it was, creating resources, removing resources, making configuration changes, and someone said, how much is all that costing? Chances are that you would see, if you've done it 10 times that day, it would see 10 instances of cost. It wouldn't see that Swapnil has done some work and it's actually in support of one project. So you really want to know what the project cost is, not what each individual instance of infrastructure is. So there's a whole bunch of things that come out that have now come to fruition over the last, say, 2 years. That means that IAC, without doubt, is the way that organizations need to go ahead. But the structure that you put around it needs to be modified so you have a little bit more governance control, less risk, and more accountability to what you're using.
When you look at infrastructure as code, can you also talk about key factors that do help teams? Like, for example, as you were talking earlier, repeatability is important, but they do want to be able to do those things, again and again. Also, in today's words, teams collaborate because it's not just one team. You're talking about multi-cluster, you're talking multi-accounts, you're talking multi-cloud. And then in your case, you're talking about hybrid cloud, which is on edge, on-prem, and of course, public cloud. And of course, open source code base is also there. So can you also talk about how infrastructure as code kind of helps with all these different areas when we do look at overall holistic approach in developing an application and actually deploying and sending it all the way to their users?
It really depends on the application architecture. I think when you're looking at the modern applications, the digital applications, where the consumer is nearer the data and you're looking at highly distributed, continuous feedback loops, continuous software releases, everything's continuous, then IAC as a component is very portable. You can move it from one piece to another. Also, IAC does encourage teams to work together a little bit more closely, because even though teams are created through individuals, if you have these very two-pizza DevOps teams that are very collaborative, they have all the skills and capabilities to go from a concept to delivery and the continuous enhancements of that delivery. That is a fairly specific type of DevOps approach. So with that in mind, IAC lends itself extremely well, because you've got the visibility to the consumer, the digital application is obviously getting continual feedback, and you've got a team that works very closely together. However, enterprises have multiple flavors of application architectures. They have long years of things being, they've got a lot of technical debt, if you like. They've got things that have been used 10 years ago that, with the innovation that's been applied, is significantly different than what you have today. So you've got to have the ability to manage infrastructure. Some have physical infrastructure still. Some have virtual based upon the physical. Some, most are adopting containers, and the containers mean you can now, instead of releasing something, you move something. So, and the cloud obviously makes it available to a greater audience with the optimization of infrastructure. So IAC, as an integral part of that, can be moved along that line for that small team. For larger teams, that thing you mentioned at the beginning where you have on-prem silos, believe it or not, there's an awful lot of silos still within organizations. And no matter how innovative the technology, if the application is still very much a legacy, highly fragmented, got lots of architectural pieces in it, you might need, more than one or two teams to do that. They still have the CI/CD process, doesn't go all the way into production for a lot of the code. So how do you get feedback on that code? And IAC definitely, doesn't always make the transition from when people are using it for doing building and testing and prototyping into the production may use a different set of configuration technologies. So there is fragmentation that exists today in large enterprises. And there's a long tail of infrastructure that needs to be managed. So if you're lucky enough to be bleeding edge and you're only going to be adopting containers or serverless or something, then you can pretty much say, we're going to have IAC to really focus on that. I think if you've got a large financial organization that has been around for many, many years, you're going to have a lot more infrastructure governance that you need that has different types of teams doing it. You might have a testing team still. You might have a team that does releasing into production. They may not be allowed to release continuously, depending on the regulations and compliance. So there's a whole bunch of variations that exist in the business that will always encroach upon good technology delivering the value it can. But there's also the organizational dysfunction, and organizational dysfunction will eat technology for breakfast. So no matter how much you want your IAC to be leveraged, if people don't understand what it's doing and they can't modify it as it goes further down a pipeline of delivery, then guess what? They'll start using technology that does enable them to get that, and they don't mind reinventing something. It's better than having a risk of taking something that is fairly complex. IAC is really a coding thing. You need to have a good knowledge of at least scripting. So if you've got Ruby skills and things like that, you're good. But a lot of people aren't. And as the skills become more and more stretched, and as the market starts to say, we need more highly skilled people to do it that are higher cost, companies are starting to say, wait a minute, how can we leverage IAC in support of all these bigger, broader initiatives to manage things that are further down the pipeline? How do we enable that? But also, how do we enable the silos within those organizations to leverage the goodness that is IAC? So that's, I came to Quali because that's the problem we're solving. But it doesn't mean, that IAC hasn't got its place. It just needs to also be usable in organizations that don't necessarily have that utopian DevOps digital environment in mind. It has to have a little bit more of a broad remit.
When I look at infrastructure code, I also want to talk about a couple of things. One is the culture. We talk about DevOps, but the fact is that, as you touched upon, is there are still silos, and there are soft silos also. We still have security teams, other teams. Then cost is becoming a big factor. It's not about the potential recession, but that companies are becoming cost effective, because cloud cost, the bills can pile up very easily. And companies are realizing that they are wasting a lot of resources in the infrastructure versus adding value. So can you also talk about how does IAC or Quali kind of helps with these two factors?
Yeah, so I'd say that the way that the market has actually been moving towards DevOps is that there have been, instead of everybody calling themselves a DevOps practitioner, there are now, to your point, very specific skill sets within the DevOps world. So I think the one that came out was, we need someone that can look at the delivery of technology from the end-to-end perspective. So if you have silos or you have teams that work closely together through that end-to-end, that's fine, but you need someone that actually has, these things are being put together to achieve a very specific measurable outcome. As you enhance things, you've got to be able to prove that what you're doing is driving business growth, or at least enabling you to show a difference. And the SRE is an example of that. So SREs have a danger, by the way, of becoming problem management people, because if you've got the end-to-end view and there's an issue in regards to how you're delivering it, and I don't want to use the word process necessarily, but the mechanisms with which continuous delivery occurs, if there are any inhibitors, it becomes the problem of an SRE to try and get around. But I think the SRE has a much more broader role. It is making sure that the technology that sits under the hood is open and shareable between different functions and different silos. So you've got, for example, if you do have a lot of provisioning of infrastructure to be made in development, and most developers will develop, even though the industry may think developers develop in the cloud, they typically, as a next developer, you develop on the component that's sitting in front of you, whether it's a laptop or whatever you do, you actually bring out and then you build things in the cloud. You put things together with your team in the cloud. So what I'm saying to you is that the ability for me to do what I need to do and then make what I do to provision my infrastructure on what I've done and make it shareable, one, to my team. So that's a very easy collaboration because my team typically has a very similar skill set, understands what I've done and can leverage my work. But as it moves down the pipeline, people in testing may not have that deep understanding of what it's doing. And as it goes into production, even worse, because production people aren't measured against that metric. They're measured against availability. They're measured against different type of metrics. Are not measured upon releases. They're not measured upon these things. So the way that organizations are measured needs to be taken into consideration. So there is an answer to this. There always is. And there's also approaches that have happened in the past that may provide increased issues. The last thing that people want is an abstraction layer. So you usually think, orchestration. What I need to do is add something. Only in the software industry do we add something to make things simpler. So in theory, what you want to do is remove something. What can you remove? Whether it's effort or time or cost, there's got to be something that is removed from that underlying code base that needs to be shared. So IAC files, configuration files. How do I make sure that I can move the goodness down the pipeline? So what you want to be able to do is provide a control plane that basically discovers what you have, makes it available. So the first thing is to discover it, but not just discover it. So if I've got IAC files, I have Helm charts for my K8s or whatever I'm using, I should be able to subsume all the infrastructure information and enable it through the pipeline. And the way that I do that is by making it simpler for people to understand. So not only do I discover something, I want to put some introspective on it. I want to translate it. What exactly is it provisioning? But I want to see it in a graphical way. I don't want to see it in a script or a long code-based file. I want to see what are the pieces I can use. Once I understand what it's doing and what it's provisioning, I can then leverage it because now I'm not worried about the underlying code. I'm looking at it from a graphical perspective that says, it needs this amount of compute, this amount of data. I can leverage that. So an example would be this. If I'm coding and I'm using my IDE and all my tooling, which enables me to put code together and bring together all the artifacts, I then want to move it into potentially a test state, whether that's a set of people or whether it's another activity within the same team. But I want to be able to leverage what I did in build because I built it on that infrastructure. I want to be able to leverage that in testing. Then I'm doing an apples to apples testing. I know what was built. I know what was tested. And then, of course, the objective is if I can actually use that infrastructure, that model that I've created, that I'm now using across my CI/CD process, what if I could move that into production as it is, and then measure the performance of that change as it goes into production? Because in production environments are messy. They have multiple shared instances. The network is contention space. So if you release configuration and modifications into production, you want to be able to measure it. But you don't want to use traditional APM type technologies that look at transactions because it still doesn't tell you what was it. Was it because I'm doing more reads on a database? What was it that I modified that created that enhancement or that degradation? So what I do may impact you. That would be very good if I could actually say, I understand what I did there. So I'm putting policy around measuring it in production that enables me to capture that and then feed that back into development. That has always been the objective of DevOps. I want to know what I'm changing. I want to fall forward. I want to understand what I can increase the value of and what I can fix and have that immediately following up. And I think that the challenge that most companies have today is that the production environment is very, very complex. But if you can keep some aspects of what you've done in production taken from what was done in testing, so you can test against the apples to apples there, and then you can move the infrastructure down the line using a technology that abstracts the information so everybody gets to use it in the way that they need to use it, then I'm not forcing people to use something different. They can still use IAC, they can still use Helm charts, they can still use their YAMLs, their configuration tools. What I'm doing is I'm taking it, translating it, and then making it usable by other people with maybe lesser skills. And I'm making it for other organizations so they can move infrastructure down the pipeline. And suddenly, to my point earlier, it becomes less of an intrusive activity. Coders should be coding to do application development. They shouldn't be spending all their time building infrastructure. That's not a good use of their time. So if I can make infrastructure as easy and as subliminal as possible by abstracting it, but in a way that doesn't add more things for them to do, that is the objective of most companies today, and that's how they're going to also scale. But there's one last thing about you mentioned cost. You said, how do I do cost? Well, the biggest challenge with cost is that it's typically tagged in the cloud. So the cloud provider will tell you how much you've been using. They will say, this is it. Now, the cloud provider couldn't tell you who's been using it or what application or project you've been using to actually, meet that cloud cost. It just tells you, here's the cloud cost. Surprise, surprise. But that's also sort of like made a little bit more cloudy by the fact that if you're using IAC or different type of configuration files, the way that you tag your costing or tag your delivery of infrastructure may be different. So you and I are looking at different things. There's no consistency between how you would tag your costs and I would. There's no ability, for example, to work out that what you are doing and what I'm doing is part of the same project. So instead of it being two cloud cost instances, how do I associate that together? You can do that by the abstraction, because the abstraction has context, who's using it, where they're using it, etc. So I can start looking at, if I can do that pipeline view, like I said, you're moving IAC and infrastructure down that line, I'm now looking at how much a pipeline would cost and not how much lots of activities within the pipeline. If I can do that, then I understand what the pipeline's objective is in regards to a project or an application. Now I'm starting to tie my costs in a more normalized way, because the abstraction of normalization normalizes the tagging. So now it's all very much the same. I'm also associating the different infrastructure stacks that I'm building together in support of a bigger outcome. And now I can actually do things like, I don't know, magic, like planning, and things don't become a surprise. At least if I have to optimize my cloud, I now know what is being used and I can then prioritize more accurately against it. So it does have, challenges, but I think as an industry, we'll fix them pretty quickly.
Earlier, we were talking about silos. And the thing is that you folks serve on-prem, cloud, edge. There are still, as much as we have been talking about digital transformation, move to cloud for a long time, there are still a lot of companies who either are in the legacy infrastructure or app development mode, or they still have the legacy mindset towards, talent pool. So it's very easy to move the technologies part, but it's kind of more challenging to move the skill set part. So can you talk about what kind of challenges that you see there, and what would your recommendation be how they can embrace the cultural side of DevOps movement as well?
Yeah, sure. So the skill set problem is probably one of the bigger ones that is the hardest problem to solve, to be honest with you, because until you can actually have the mass of people leaving, joining the industry and looking at this as a way ahead for them. At the same time, infrastructure is growing more complex. So the complexity, so the long tail that I spoke about, or the technical debt that companies have got by continually innovating and moving forward while still keeping the older technology in place, means that your skill set is getting very, very stretched and very broad. So what happens is that the reason that the silos continue to exist the way they do is because the expertise or the deep dive knowledge, the domain knowledge that you may need to provide infrastructure. You might need extremely good networking skills. You might need extremely good container skills, cloud management skills. All these things, if you're having serverless approaches, that is a completely different type of skill set. The ephemeralness of something that moves around and only wakes up when you need it. There's a whole bunch of things that have changed. So I think that the skills that people would like is, they'd have to go headhunting at NASA to find the sort of experience and knowledge that they need. And of course, you can only have a few of these extremely broad, knowledgeable people. And arguably, they're typically been in the industry at least a decade or more to learn all these skills. They are very rare. So what you need to do is provide technology that either does one of two things. It can either enable different skill sets to work collaboratively in support of a common objective. So that's what DevOps is about, bringing people's skills together in support of the common objective. But the second thing is you can actually enable people to do things that they never had the skills to do, because what you're doing is providing a technology with either the intelligence or the ability to report it in a way that makes sense to you. So if I was lacking database skills, but I knew that I needed to modify a schema, and the schema had obviously certain attributes that needed to be modified, and I needed to understand how what I was touching wasn't going to break anything. Then it would be good for the technology that I'm using to provision the infrastructure to have a data environment that I can then pull upon in a more graphical, easy to understand way than a deep dive. And I could be leveraging maybe one of the skill sets that I've already got in my organization. So as you scale up, you've got to be able to leverage the skills that you've got, because I would honestly tell you that the business demands on IT is going to absolutely swamp the amount of people that are coming into the industry today. Not just because they're not smart enough, that's absolutely nothing to do with it. There's some really smart people coming into the industry. It's the broad skills that they require to manage these very complex application architectures that are, some are very old, some are modern, and some are bleeding edge. But you've got to have, irrespective of how you cut that up, you don't want to have three silos. You don't want to have, you're managing the old stuff, you're managing the bleeding edge stuff. I mean, eventually, we'll end up with we'll end up having baby boomers made to stay around because mainframe is still about. So so you have to have technology that abstracts the complexity of those different legacy infrastructures and treat them in the same way that you would if you were provisioning some of the more bleeding edge ones. So even though you have Helm charts, IAC files, and you're managing digital infrastructures, you also want to be able to have technology that could also take into account physical capabilities. So you're nullifying the skill set from a timeline perspective, and you're bringing people up to speed on physical to serverless on that line there, for example, network to data. So you're doing that one too. And you want to make sure that also you've got technology that can at least address the 70 to 30% rule. So 70% of the things that you'll do can leverage the technology, and only the 30% that may be so complex requires those very unique and precious skills to be focused on it. So you really want to do as much as you possibly can for the bulk of the resources, and then focus the skills with the highest level of capabilities and expertise on the things that demand that type of skill set.
David, thank you so much for, I cannot even put it to words that, how incredible it has been to not only like the way you shared all the insights, all the way to the technological problem and to the cultural and people's problem. I also feel because of some changes, because the chips, bill and all those things, as the manufacturing is coming back to the States, we are going through a jobs challenge. But I think with this, there is a massive, if you just look at the gap between demand and supply versus, employment, there is a big solution, it's in front of us, but we are somehow ignoring it. I talk to a lot of folks at Linux Foundation where, job support keep coming up, and I'm like, look at, there's not a silver lining, it's a platinum, gold, diamond lining on the cloud. All we have to do is point towards that and we'll solve most of the jobs problem. But I really appreciate the discussion today. I'd love to have you back on the show where we can talk more about Quali as well. But once again, I appreciate your time today. Thank you.
You are very welcome. It's been an absolute pleasure. And I look forward to speaking again soon.